Thank you, Mitch, for setting me up, and Ian. But Mitch, you set me up with different fields. Here's another one. We did our project on greenhouse gas emissions, as you can see from the giant billowing smoke CO2 image we have there. And just because we thought it was a catchy name and a good pun, we named our project Emission Impossible. And that button there, the dun 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 dun, dun, yeah, that's the Mission Impossible theme. So if you want to click on that, quick link. So now I'll pass it off to Julian to go over more what we.
Hello, everybody. So our emission, which we chose to accept, was we wanted to investigate and attempt to predict the different greenhouse gas emissions for different countries based on the import, export, and production rates of different fossil fuels. We started this project with the hypothesis that this would be positively related, that the more a country produced, imported, and exported fossil fuels, the more greenhouse gas emissions they released. However, we wanted to develop machine learning models to get deeper and more nuanced understanding of the relationships that are underlying in these factors. So now we'll be looking at the data set that we use from the UN Data API.
For our project, we utilized data sourced from the United Nations Data API. We collected data on import, export, and production volumes for 5 different fossil fuels in correlation with GHG emissions for the same period. Data was collected for all available countries ranging from the year 1990 to 2019. One drawback with this API is that the data is self-reported by the United Nations by member states. This method of data collection inherently causes some issues as nations may not report or misreport some values. In addition, certain nations simply do not have the infrastructure to accurately report every value. Due to this, our team needed to perform missing value analysis and handling so that accurate machine learning models could be trained. To do this, rows missing more than 5 values were removed from the dataset.
Prior to this adjustment, our dataset had about 1,300 rows and 7,200 missing values. After the adjustment, the number of rows was reduced to about 800, and the number of missing values was reduced to about 1,500. So although the number of missing values was reduced by about 80%, the number of rows only decreased by about 30%. This shows that many of the missing values belong to the same rows, as countries that lacked the infrastructure to report some values were also not able to report others. So following this drop, columns still containing a large portion of missing values were also removed, resulting in about 300 missing values. To fill in the final few missing values, an imputer was used. This helped us replace the missing values with the mean value for
This heat map shows how strongly our variables are correlated in relation to greenhouse gas emissions, aka our target variable, aka mission target, aka emission target. The warmer colors and higher values showed a stronger correlation. In this example, the production of fossil fuels is more closely correlated to greenhouse gas emissions than imports and exports. Additionally, we found that production values are much more highly related with one another than imports and exports are. Based on this information, we derived that a country's production of fossil fuels is more highly correlated to its energy demands than imports and exports are.
So one of the first visualizations we made was a pie chart subplot of the global greenhouse gas emissions broke down by country over 3 years, 1999, 2009, 2019. We saw what we expected, which was the United States and other post-industrial nations like the ones in the EU, Russia, and Japan contribute the most to greenhouse gas emissions when you break down percentages. But if we go to the violin distribution, we see that how different the amount that they're emitting is. And up beyond 6 million tons is the United States, and following that is the EU, and below that's Russia. One thing that we noticed from these visualizations is that we were missing certain countries who contribute a lot to greenhouse gas emissions, and such as China and India. And these visualizations allowed us to understand our data set more and understand what the drawbacks were, which we were talking about earlier.
All right, so this first scatter plot is of hard coal production of different countries over time. So it's an interactive plot. You can mouse over and get all the data about any specific point. The top line there in the bluish green color, that's the United States. And the size of each dot is the greenhouse gas emissions of that country for that year. So you see that the green line at the top, the US, is steadily declining. And over that same period of time, their greenhouse gas emissions have gone down fairly in line with their hard coal production. Then you can see below them are the pink and purplish lines. Those are Russia and Australia. So both of them have been on the rise in their hard coal production over the past 30 years, and as such, their greenhouse gas emissions have also gone up over the same period. Aside from that, just about every other country has had a decrease in hard coal production over the past 30 years, and their greenhouse gas emissions have gone down as well, showing that these two are highly, highly correlated, as we saw above in the heat map.
Moving on, we now have another scatter plot, which shows the crude oil production of different countries over time. As Robert mentioned, it's interactive, and the size of each bubble represents the greenhouse gas emission for that country for that year. As you can see, there are two major outliers, that being the US and Russia at the top with the turquoise and reddish color. So from the time period of the 90s to the 2000s, there's a general decline in most countries of crude oil production. Then in 2000, Russia sees a large uptick in production, which continued to this day. Similarly with the US, there's an uptick, but this happens around 2008 following the financial crisis. Otherwise, following the year 2000, most other UN countries, with the exception of Canada, have experienced a general decline in crude oil production. This shift may be the result of increased regulation, a shift to other fossil fuels, or an increased reliance on Russian or US crude oil export. If we go down, we can now have a carousel that shows the different machine learning models we used. We used 6. We had Lasso, elastic net, linear regression, k-nearest neighbors, neural networks, and random forest regression. So I will only highlight 2 since the other ones have been mentioned. So the first is Lasso. Lasso regression is a supervised machine learning model that uses L1 regularization. Essentially, it can analyze all of the features and it can determine which ones are uninformative. Those are then removed by from the prediction by assigning them a weight of 0, meaning they have no sway on the prediction. This is often compared to ridge regression, which uses L2 regularization, which can also change the weights of features. However, it only shrinks them, but does not set them to 0. If we move on now to elastic net, elastic net is actually the intersect between a lasso and a ridge regression. It utilizes both L1 and L2 regularization, and is often used when a data set has millions of parameters and you're unsure of the usefulness of any given parameter.
These are the results from the 6 different models that we used. Our target variable was greenhouse gas emissions, and these graphs represented the predicted value of the models versus the actual value from the data set. The closer the line is to the y equals x line, the better the results we got from that model. To measure the accuracy of each model, we use something called the mean squared error, which is just a method of measuring how accurate each model was. The 2 models with the lowest mean squared error from our testing was random forest regression in purple and also the neural networks in blue. And these 2 performed much better than our other models.
Our mission uncovered trends and patterns in how different energy sources contribute to greenhouse gas emissions. Our initial hypothesis was that GHG emissions are positively related to fossil fuel production, import, and export volume. Although this had been previously studied, we were able to derive additional supporting evidence and gain a deeper understanding of the issue ourselves.
A noticeable point of interest we found in the UN Data API is the UN Data API self-report method of data collection, as some countries have a tendency to underreport. Another was the fact that hard coal serves as the largest indicator of greenhouse gas emissions. Additionally, we found that the production of fossil fuels and energy sources is a greater predictive factor for greenhouse gas emissions than imports and exports are.
A wide variety of programming skills and technical knowledge were gained through this mission, such as training machine learning models and gathering and manipulating data. In addition, we were able to practice other soft skills such as presenting and public speaking. So as we plan for our next mission, we hope to implement these skills to gain a better understanding of new data and trends to help us overcome whatever obstacles we may face.